Hello, I am Ilma. Today, we finally enter the woods of Scheme. After booting Viivi, press the play button twice to enter the input state. In the input line on the controller, type 30 from the keyboard. Finally, press the Enter key on the keyboard. After the display in the input-output port windows, the input line is again ready for input. Second, try typing 5. The input-output port windows are displayed and the input line is again available for input. Try increasing the number of digits to be entered. The same thing is repeated. Now let's look at the output for the first example, 30. The 30 displayed in white text, in the input port window, is simply the code you have entered in the input line. The output port window shows unfamiliar output. On the right-hand side of the first line, 30 is displayed in white text. This indicates that Viivi has received the 30 you have entered. Next, you see a light brown square C-shaped line across two lines. This line traces the path Viivi took to find out what to do in response to the 30 she received from you. Let's call this line the trace line. You know that the 30 you entered represents the number 30. Viivi has thought about it in the same way, and has come to the conclusion 30, the green number on the right-hand side of the second line. The counters are shown with colons, to the left on the first and second lines. Initially, the value of this counter is 0, but each time Viivi finds an answer to return, the value of the counter increases by 1. Now the counter has increased from 0 to 1, because Viivi has found an answer to return for the first time. The output from the first and second lines is a trace of what is happening in Viivi, and a visualization on the process. We call this entire output of the first and second lines, trace output. Trace output is unique to Viivi, and not found in any other Scheme language processor. After the trace output, in the third line, Viivi returned to you with the resulting number value, 30. Other Scheme language processors than Viivi will always output this last value. The subsequent 5, and the input with a large number of digits, are also output. Similar display, as for the input 30, is repeated. Let me rephrase what has just happened, using Scheme terminology. In Scheme terminology, the code that is input by the user is generally called an S expression. The original, unabbreviated form is symbolic expression. Finding what to return for an input S expression is to evaluate. The path of evaluation is an evaluation process. The trace line is a visible representation of this evaluation process. Finally, the result of the evaluation is called the evaluation value, or simply, value. The leftmost counter is called the evaluation counter, because it increases each time evaluation is completed. To illustrate the first example using these Scheme terms, let's say that we have evaluated the S expression 30, and obtained an evaluation value of 30. As you will gradually learn, this system of evaluation is a unified generalization of Scheme as a whole. It is one of the factors that make Scheme a simple and clean programming language. Scheme language users, schemers, seem to use the word eval, which is a contraction of evaluate. We will follow their convention. The S expression 30 is evaled to the value 30. This time we will use evaluate, because it is an explanatory video, but from next time onwards, we will use the short form eval, as much as possible. We will summarize Viivi's behavior here, since we have gone off topic. First, Viivi reads the S expression U input. Next, she evaluates the read S expression. Finally, she returns to U, the evaluation value, obtained as a result of the evaluation. When the sequence of processes 1 to 3 is completed, Viivi performs the same processes again, for the next S expression U input. The word corresponding to each action is shown on the right. All Viivi does is this read eval print loop. This basic operation of Viivi is called REPL, which is an acronym for the words. The basic behavior common to all scheme language processing systems is to run a program by this very simple operation of REPL. Integer is a type of number that can be counted up as 1, 2, 3, and so on. The value of an integer is an integer value. The evaluation values obtained in the previous examples, 30 and 5, are examples of integer values. In the computer world, integer values are one of the most basic kinds of data. As we saw in the previous examples, the S expressions for returning integer values are the same as the usual representations of integer values that we use. Of course, negative values can also be used. For example, entering the S expression, -1, 7, returns the integer value -17, as expected. Large integer values can also be used. Viivi has no limit on the number of digits for integer values. An integer value, with the same representation as the input S expression, is returned. Note that the number of ones and tens has not been truncated or rounded off to a different value. An integer value with the correct number of digits is returned for every digit, no matter how large the number of digits. Of course, the same applies to large negative numbers. The integer value, corresponding exactly to the input S expression, is returned. Scheme belongs to a large group of programming languages, called Lisp. Many Lisp languages traditionally support integer values with no digit limit. On the other hand, not many averaged programming languages support unlimited integer values. For example, integer values in averaged programming languages for 64-bit systems can only be used in the range shown above, whereas Viivi has no such restriction. Viivi should have no problem evaluating any correct S expression, representing an integer value. Enter any integer valued S expression you like, and check that it returns the correct value. S expressions for integer values can usually be entered without any problems. However, it is not always the case that Viivi returns something no matter what you type in. For example, try entering a round closing parenthesis. Viivi does not know what to return, and an error occurs. Press the play button to clear the error, and return to the input state. 30 was a proper S expression, but a round closing parenthesis is not. When humans talk to each other, they follow the rules of the language they are using. In the same way, you cannot talk to Viivi without input according to the rules of the scheme language. The rules of the scheme programming language are summarized in a specification called R5RS. The official name of our 5RS is shown on the screen. The document is publicly available, has a small number of pages, and the English original has been translated into various languages. If you can read our 5RS and understand it all, you understand the scheme language. However, this is not an easy task for a programming beginner. In this tutorial, you will learn not only how to operate Viivi, but also the rudiments of the scheme language written in our 5RS. Now, how does it feel to have tried scheme programming? You may not feel that you have done any programming. But you have entered the S expressions, 30, 5, and -17, and Viivi has returned the corresponding evaluation values, 30, 5, and -17, respectively. Enter an S expression, and get its evaluation value back. It's amazingly simple, but that's what running a scheme program is all about. So you've already run a number of scheme programs. The S expression 30 is, in other words, a program that returns the integer value 30. Similarly, the S expression 5 is a program that returns the integer value 5. 5 is probably the shortest computer program in the world. How simple scheme is, can be seen by comparing it with other programming languages. Viivi is written in Java programming language. If you write a program in Java that returns to you an integer value of 5, for example, this much code is required. While the Java programmer has to look up the meanings of many words in the code, and correct typos in the long code, you, the scheme programmer, can concentrate on the essence of this program, which is to return the value 5. There is such a large difference in the complexity of even these small programs. Imagine how simple and convenient the scheme language is when writing complex programs. You can see why the scheme language, which allows you to concentrate only on the essence of algorithms, has been used for a long time in university and corporate laboratories that try to do creative work, such as generating new ideas. This time, I talked about the most important trick, evaluation, and the most basic data, integer values. Evaluation will come up every time from now on, but don't be afraid of it if you don't find the contents of this video difficult. If you understand evaluation, you know half of the woods of scheme. Let's walk steadily, little by little. Thank you for watching this video. In the next video, we'll see other kinds of numbers, besides integers. Enjoy! See you next time. To continue learning, please subscribe to the channel by clicking the subscribe button. Thank you.